ladies and gentlemen, welcome to another round of information here. This is Mr. Doolin. I thank you for tuning in. Real quick, we're going to take a look at standard solutions and the calculations that we're going to do when we deal with solutions in the lab. First off, what is it? A standard solution is a solution that we know the molarity of with some certainty. All right, so we've standardized it, we've checked it against some other standards that we have, and we are going to assume that the molarity of the solution is actually true and correct, and we're going to use it to compare other unknowns to. All right, so that's what it is. It's something that we are very confident or somewhat confident about what the molarity actually is. Now, I know it's been a while for some people, so I just want to go ahead and refer to molarity is equal to the number of moles divided by liters, right? So we got moles divided by liters. That's the molarity I'm talking about, so we can actually put a specific number of molecules and the specific mass into these solutions, all right? So now the big question, how do we make it? Because they're actually going to ask you sometimes on a free response question, hey, if we gave you all this equipment, how would you make a standard solution? And so we need to make sure that we understand the steps in the process and how we're going to go about this. And so number one, with a standard solution, we are going to, well, that's not a very good color. We're going to weigh out our solute, normally with an analytical balance, but we're going to weigh out the solute. We are going to, step number two, we're not going to put it into the volumetric flask yet, but we are going to fill a volumetric half full, right? And so if I'm looking over here at my volumetric, I would have actually filled it up, to about halfway full. And the reason for that is that way when I put my solute in, or my solid in, it's not going to stick to the bottom. It'll actually start to dissolve itself, all right? And so the third thing that we're going to do is we will add our solutes, right? Four is we are actually going to mix this thing when it's about halfway full, right? And we're going to continue to add. So we're going to mix, and then we're going to continue to add our solvent, and then add solvent to the neck area, or to the, or actually, I'm just going to go ahead and say to lime. Because the thing with the volumetric flask, and this is what I've got drawn here, is this line right here, if this was the 100 mil volumetric flask, this line is exactly 100 milliliters. All right, and so if we get the meniscus to the bottom of that, and so we fill this sucker up, and we get it right to that, and we've got our solute dissolved in there, then we specifically have added exactly 100 mils of water, and we have a very precise measurement on our mass, and so again, we would have a molarity that we could be confident to. Now, the big thing with the standard solution is just you're going to use the volumetric to do it. Make sure you fill it about halfway full, put the solvent in there, and mix it, and then add it up to the line, all right? And you need to check and make sure. What happens if you go over the line a little bit? Can you take some of the water out? And the answer is no, because remember, this is going to be a solution that we are confident about. So if you mess up any step of in this process, you actually just have to dump it and start over. All right, and so you have to be really careful when you're filling it up. Normally we get to the point to where we do drop-wise when we get really close to that volumetric line. All right, okay, so that's what it is. That's how we make it. And then now I need to make sure you understand what we're going to do with it. And so now I'm going to go ahead and just say that we have created a 1 molar, I'm just going to say NaOH solution, all right? We weighed out the proper number of moles, or the proper mass. We filled it halfway full. We put it in there. We mixed it up, filled it to the lime, yada, yada, yada. I got a 1 molar NaOH solution, all right? So what am I going to do with it now? So sometimes we're actually going to do dilutions, right? And so a dilution, you remember the calculations is actually M1 V1 equals M2 V2. I need you to understand what these are. Your M1 is your stock. Now, the standardized solution that we make, we can either call it a standard solution or we are going to call it a stock solution. Generally, the stock solution is what we are going to draw from, right, to do all of our dilutions. Then volume 1 is actually the volume of the stock, right? molarity 2, if I'm going over here, molarity 2 is actually going to be the molarity, and I guess this is molarity of the stock over here. So molarity of dilute solution, and so normally this is what we're trying to get it to. And then volume 2 is the total, not just the volume of my second solution, but the total volume of dilute solution. So a lot of people get thrown off, like if I needed 10 mils of the stock and I wanted a 100 ml solution, that means I only need to dilute it with 90 milliliters of water to get it to that total volume. All right, and so I just want you to make sure, and I know this is a refresher for most people, another big thing that I'll leave you with here is if molarity, which is a capital M, equals number of moles divided by liters, a very common way to get to moles, like let's say if I took 55 milliliters of my NaOH solution, we need to understand that since molarity is actually number of moles times liters, if I multiply that times liters, it's going to give me moles, right? And so this is a huge calculation that we're going to do when we're dealing with any kind of solutions. A lot of the times we're going to have to use, hey, I added this much volume, how many moles did I actually add to it? And so this is a very important calculation and formula that you're going to need to know. You'll need to know how to dilute solutions. You'll need to know how to make a standard solution. You'll need to know how to calculate molarity. And so all this stuff is really pretty important, even though it's pretty basic stuff, okay? All right, so hopefully you got some questions written down if you had some. If you do, please bring them to class. We will go over them in class, so you can come to tutorials. We can talk about it then. But above all, thanks for tuning in. I'm glad that you're pushing through it, and I will see you in class.